So we have stretches of a function. A stretch is a transformation that changes the size and shape of the graph. The original and the new graph are not congruent. So if you have a vertical stretch, it actually pulls the graph upwards. So it often will narrow it, or it'll make it look wider. If I take all my y values and I shove them down, it actually makes it wider. If I take all my y values and I pull them up, it actually makes the graph look narrower. We're also going to look at horizontal stretches where we're going to multiply our x's by values, which might make it look wider, or x's by values that are like between 0 and 1, which will make it look narrower, right? Because we'd shrink our x values. So that's what we're looking at today. Last year, you would have done vertical stretches for sure because they were in the grade 11 curriculum. So vertical stretches are in the form y equals a f of x. So once again, we have the a sitting in front, correct? Is it in the bracket with the x? No, so it affects the y's. We agree? When I had a negative yesterday here, we multiplied all our y's by -1, correct? If I have an a here, which is a vertical stretch, we're going to multiply all our y values by a. If I had negative and a there, I would just have a reflection and a vertical stretch, and I'd multiply them by -a. That's it. So whatever's sitting in front here gets multiplied, and then at the back would be a vertical translation. We would add or subtract it, right? So that's why we have to do them in the form stretch, reflect, translate, because stretch, reflect is multiplication, division, and translate is subtraction and addition, which is BEDMAS. So that's why you have to do them in that order. Stretch, reflect, translate. What was the thing again? We made a new one?
Oh, snakes run terribly.
Snakes run terribly. Yes, snakes run terribly. It's true. So we can go that way too. Now, this one is the worst for the sentence that you have to write because it's long and arduous, but you just have to do it anyways. Doesn't matter. So the way we say it is, we say vertical, and some of you are like, what if I miss some of it? You can't. It has to be written like this. And that's not even a joke. Like, I'm not, haha. It's like, you have to write it like this. So it's vertical stretch. And then it's by a factor of, and in this case it would be a. And people stop here. You won't get the marks because you have to keep going. You have to tell which axis it's about. Bless you. So we're going to say about the, and it's the same. The great thing is it doesn't change. So if I had a negative in front, it would be a reflection in the x-axis because I'm multiplying my y's by -1, right? So if I multiply my a's by something, it's about the x-axis still, right? Because I'm still doing it about the x-axis. So it's going to be about the x. So it's a reflection in the x if it's in front, and it's a vertical stretch by a factor of a about the x-axis. So the good thing is the axis doesn't change. If the number's in front, it's always about the x-axis or in the x-axis for reflection. Okay? Yeah.
Can you not say on the x-axis?
I don't know. I know they accept about. I know there was a whole bunch of varying different letters and words that came up, and we had to put our hands up and ask the head marker if it was okay. And I cannot remember the list of what she was okaying and what she wasn't okaying. All right. The point xy becomes xay, which this is called what? Mapping. So in order to show actual real mapping, we're going to say xy becomes xay. Now here it says the points on the x-axis are invariant. Why is that? Right, they don't change. And why don't they change? Because your y is 0. Same rule as last day. When we had a reflection, we were multiplying our y's by -1, correct? And if your y is 0, it doesn't change. Well, in this case, instead of multiplying by -1, we're multiplying by a. It's the same understanding, right? You're still multiplying by something. So when you multiply 0 by anything, it stays. So it's invariant on the x-axis because your y values are 0. And then once again, if the a has a negative sign in front of it, then it's a reflection in the x-axis. So you never say vertical stretch by a factor of -a, let's say. Because your stretch factor, that's not your stretch, that's your reflection. So whatever value you put in for vertical stretch, it's always positive. So if you're like vertical stretch by a factor of 3, vertical stretch by a factor of 5. If it was -5, it would still be vertical stretch by a factor of 5, and then I'd go reflection in the x-axis, right? I'd have to state both then. So that negative doesn't stretch it anymore. It doesn't make it wider or narrow, or it flips it. It's totally different. So your stretches never have a negative. So here, describe the transformations that occurred if the original graph of y equals -4 f of x was y equals f of x. What do we have here for transformation? Vertical. I feel like I'm happy camper here. Vertical asymptote. Vertical asymptote. Wow, I went to rationals there. See? Peaked. Told you. Vertical stretch. In the rational unit, you will have vertical asymptotes. We're not there. Vertical stretch by a factor of what? About the x-axis. I really went to rationals first. That's in 2 more units. We will have asymptotes. And then we have, what's that negative do? Reflection in the x-axis. You can. Your textbook will always have in. Tests will always have in. But you can. If it's about to stretch, it can be about to reflect. Okay, what's my mapping? Mm-hmm. So whatever's in front here, we'll just multiply by your y's always, right? That's it for that one. Flip over. So we have given the graph of y equals f of x, so it's the one below. They gave you a table of values, which was kind. They didn't have to. They had to in this instance because they actually didn't tell you the scale factor on this graph, so they'd have to give you the scale factor or they'd have to give you the table. And they ask you to sketch y equals 2 f of x. I'm moving coordinates. What am I going to use? Mapping every single time. So what is my mapping? xy becomes x comma, because I just multiply by what's here, right? 2y. And all I have is a vertical stretch by a factor of 2 about the x-axis. Okay? So I'm going to plug in my points. I know that you could just figure out how to multiply them, but that's okay. You also know these ones are invariant, but I'm showing it anyways. 2, 0 becomes -2, 0, I meant, becomes -2 and then 2 times 0, which is actually -2, 0. Why did it stay the same? Because your y is 0, because it's on the x-axis. Because if I stretch something, I'm going to multiply. When I multiply by 0, it stays 0. Yeah?
Under the comma, do we have to show them in a step, or can we just go straight to -2, 0?
You can go straight to -2, 0. However, if you make it oopsie, there's no work shown, and it's hard for them to give you any marks. Yeah. And sometimes they'll ask you to explain, or, you know, what's the invariance in y, might be the next. Also, if it's a bullet, each of the bullets on the test, you have 3 questions, 2 bullets each. Each of the bullets, one's worth 3 marks and one's worth 2. So the one worth 3 marks has to be worth 3 marks, right? So sometimes it's like a paragraph. Sometimes it's like this wouldn't be worth 3 marks. Given the graph of y equals f of x, use a table of values, sketch y equals 2 f of x. And then it might say, then list the invariant points and explain why they're invariant. So that would be worth 1 mark. Listing the invariant points would be worth 1 mark. Explain why their invariant was worth 1 mark. So that's 3. So when it's out of 3, always know that each bullet has to be out of 3 or 2. And you need to figure out how they would get 3 or 2. And often it's like blatantly obvious. It's 3 pieces of information, right? Okay. Then we have -1, 2. Becomes -1 and then 2 times 2. So it becomes -1 and 4. Like I said, this mapping is easier. So it's -2, 0. -1 and 4. I make 2 points, I connect 2 points. This graph is getting taller. People will say it's getting wider. I don't know what's happening. Well, should it be getting wider? It's not technically, it technically is kind of getting wider, but it's technically getting just grabbed and then stretched upwards, right? because we're going to take the next one, which is at 0, 5, and it becomes 0, comma 2 times 5, which is 0, 10. And then this one's going to remain invariant. So it vertically stretched it, right? Fold it up. Yeah. Now this next one has y equals x squared, replace y with 3y. So what does replace y with 3y mean? Anyone know? Nope. Because you have to replace. What does replace mean? Go to the y, toss behind the head, replace it with 3y. So the y is getting replaced with 3y. So we're going to get y equals x squared. I'm going to take this y, I'm going to toss it behind my head, and I'm going to replace it with 3y. So in order to give the vertical stretch, I want to put it in y equals. If I don't put it in y equals, it's the reciprocal of this. Because how do I get rid of a 3? Divide by 3. Or I could say, instead of dividing by 3, I could say multiplying by 1/3. Right? Multiply by 1/3 would be how you get rid of 3. So if you leave it like this, people will often leave it like this, and then they're like, I don't know what to do with it. So instead of saying dividing by 3 for transformations, I'll often say multiplying by 1/3, because then my vertical stretch sits in front better, and I don't get confused. And it's not with the x squared, it's in front of the x squared, isn't it? Could I make it with the x squared? How could I bring it inside? I'd have to distribute it in and square it, correct? So to put it inside, I could write it as 1/9 x squared. And then it's actually a horizontal stretch, not a vertical. It really only happens, and that does happen on test questions all the time, but it happens with polynomials like x squareds, x cubes, x4, because we may look like a vertical because I put it in, it still looks like a vertical, and then they'll only give you the option of horizontal stretches. Horizontal stretch this, 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 or the two options they'll give you for vertical will be by a factor of 3, which it's not, it's a third. So they'll give you the two verticals, which is a vertical stretch by a factor of 1/3, vertical stretch by a factor of 1/3, you're like, I can't pick those, and then it's horizontal stretch by a factor of 9, which you're going to see why. This becomes 1/9 when I put it in, because I have to square it, but your horizontal stretches will flip. Because when you're with the variable, what would have happened here? If I left it as a 3y, what would I have put for my vertical stretch? If I left it as a 3y, what would I put for my vertical stretch? A third, right? It would flip. So when it's with the x, it's going to always be with the x. You're always going to flip it. And we'll see that in a second. So here we have a vertical stretch. By a factor of 1/3 about the x-axis. So if I graph the original, the y equals x squared, it's at 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4. This is y equals x squared. Now you could go to your table of values and pull those points off and sketch them, right? You could type in y equals x squared and go second graph, pull the values off. Or you can say, hey, every x I put in, my y is whatever it is squared, right? Because that's the equation. So if I put a 0 in here, 0 squared is 0, so I get 0, 0. If I put a 1 in, 1 squared is 1, so I get 1, 1. If I put a negative 1 in, negative 1 squared is 1, so I get negative 1, 1. If I put a 2 in for x, 2 squared is 4. So you can just plug in like you were taught in grade 10. It comes up every day. How do I move a graph? Mapping. Could I actually technically type in y equals 1/3 x squared and redraw it? Yeah. Often what they'll throw in is they'll throw that little f in there. If they throw an f in the middle of here, you can't type it into your calculator. Because it just says it's a function. This one actually gave you the graph. So we're going to move it. So we have xy becomes x 1/3 y, because remember words and mapping are the same. Same thing when representing the same thing. So if you're going to say 1/3 in words, you're going to use 1/3 in mapping. So I'd start at 2, 4, and it's going to become 2 and 1/3 times 4, which is 4/3. So 2 and 1.333333. I should use a different color. Oh, that's negative. I use 2 and 4x. So 2 and 1.3333. And then 1, 1 is going to become 1 and 1/3 times 1, which is 1 and 1/3. So 1 and 0.333. 0, 0 is going to remain the same because it's invariant. And then negative 1, 1 can be negative 1 and 1/3 times times 1. So we just get negative 1 and 1/3. If you notice, they're symmetrical, so let's go do this. So when our A value was between 0 and 1, our graph actually looks wider. Yeah, because it looks like it's being pulled wider, right? It's not actually being pulled wider technically. We're just dropping our Y values down, so it looks wider. When our A value is greater than 1, it takes that graph and it just like shoo, pulls it straight up. So it actually looks narrower when you're done drawing all of the coordinates. You guys are going to try example 4. I want you to type this into your calculator, or we can just do a t-table. What's my first x going to start at? 0. Why can't I start negative numbers? Right. So if I want to do a t-table for this, I'll let you type in your calculator for practice, but you don't even need to. We know it has to start at 0 because I can't take the square root of a negative number, and y is just the square root of whatever my x is, right? So the square root of 0 is 0. And then I don't pick 2 because I get root 2, and then 3 get root 3, so I'm going to pick 4 because I'm going to get actually square root of 4, which is 2. And then I could do 5 if I want to. It's root 5, which I don't know is a decimal. I'd have to look it up. 6, 7, 8, I'm going to pick 9. What other thing could I have picked that would have been nice that I skipped over? 1. Square root of 1 is 1. So I'm actually going to plot 0, 0, 1, 1, 4, 2, 9, 3. So if there's no f in the function, we can actually just use what we know of knowledge in t-tables and make our own graph. So I want you to replace it. Mapping, draw. So we're replacing y with 1/2 y. How do I move a half? I multiply by 2, and it goes in front. It doesn't go underneath, right? So I get y equals 2 root x. How could I bring the 2 in? So the answer here can be vertical stretch by a factor of 2 above the x-axis. So we square rooted it to bring it out. How can we put it back in? Square it. So we could put a 4x under here, couldn't we? So this could be rewritten as y equals square root 4x. And then you're going to find out it's a horizontal stretch by a factor of a quarter. It'll always flip. The horizontal stretch will always flip. I'm just pointing out that they can take a vertical stretch, insert it into a squared, or insert it into a square root and swap it to a horizontal. But we're not doing that. We're keeping it here. So our mapping is xy becomes x comma 2y. So we're going to actually multiply all of our y's by 2. So this one's going to stay the same. And this one's 1 and 1, it's going to be 1 and 2. This one's 2 or 4 and 2, it's going to be 4 and 4. And then 9 and 3 is going to be 9 and 6. So it's going to look like that. Now I want to prove to you that the horizontal stretch, I know you haven't learned it yet, but I want to prove to you that if I use a horizontal stretch of a quarter, I'm going to get the same graph. Because if I move this 2 inside, I square it, put it back in, right? You said that? we got here is the horizontal stretch by a quarter. So technically we would get a quarter x comma y with an xy. I'm just proving this ahead of time. It's a short Friday. There's an arrow in between, right? So all of our x's are being quartered and our y's are staying the same, technically, correct? So we use a different color to prove to you that a horizontal stretch by a quarter or a vertical stretch by 2 will give me the same graph. Will give me the exact same points. Yes, but I'm not going to pick them that way. So if I go 0, 0, it's going to remain 0, 0 because it's going to be a quarter times 0, which is 0. Then this one is going to actually move my 1, 1. So if I use my mapping, my 1, 1 is going to become a quarter times 1 and 1, which is a quarter and 1. So 0.25 and 1. I land there. Then if I use 4, 2, it's going to be a quarter times 4 and 2, which is 1, 2. I'm landing all the same spots. And then I have 9, 3 is going to be a quarter times 9, comma 3, which is 9 fourths, and 3, which is 2.25 and 3. Gave me the same graph, didn't it? Yeah.
Where does the quarter come from?
Sorry?
Where does the quarter come from?
So you haven't learned that, but what I was telling you guys is that when it's with a variable, you're going to flip it, right? So if we had left the half b on this side with the y, I would say it's a vertical stretch by a factor of 2, because I have to flip it because it's with my variable. We agree? But instead, I multiplied it over and made it be 2 over here so I could see it. When it's with the x, there's no option of moving it. So you always have to flip it. It's a quarter. Whereas with the vertical stretch, you have options. You can keep it over here and then you have to flip it, or you can put it over here and keep it. I always move it over and just keep it. That's just the rule I use. But showing that if you kept it over here, you had to flip it because it's with the variable proves why. This is always with the variable, you always flip it. Does that make sense? Yeah. So that's why it becomes a quarter. People often forget to flip it. And they'll have that as a common error every single time if you forget to flip your x. Or if you flip your y, they'll have that too, because some people are like, I don't know what I'm flipping. I just flip things and stuff. So does it make this, do you see how they're the same graph no matter which way I did that? It'd be the same thing with the x squared up top. If I had 2x squared or 4x squared, I would actually get the same graph. So, shift, move. Here, horizontal stretches. Voila, we've learned it already. Horizontal stretches are in the form of y equals fb of x, where b stretches the graph by a factor of 1 over b. And it's because it's with that x, right? We can't move it. The y, we could take it from the y and multiply it or divide it over and get it away. And then we don't have to flip it anymore. But with the x, it's always with the x, so it's always going to flip. So this one we're going to say a horizontal stretch by a factor of 1 over b. Because this is just b over 1, correct? So it'd be 1 over b. If it happened to be 2/3 x, it would now be 3/2 x. It's just always flips. If it's negative, you still say the positive for the stretch, because the negative is a reflection in the y-axis. So horizontal stretch by factor of 1b, don't stop, about the y-axis. For my mapping, my xy would become x over by. We could write it that way. Or we could write my xy becomes 1 over bx comma y. It's the exact same thing. Dividing by b or multiplying by 1 over b is the same thing, right? Now the points on the y-axis are invariant because my x values equal 0. And if b has a negative sign in front of it, it's a reflection in the x-axis. That didn't change. Didn't mean to do that. I don't know what just happened. So For example 1, we have to describe the transformations that occurred in the original graph of y equals f(5x) was y equals f of x before. So this is just a horizontal stretch because it's with the x. It's going to be a horizontal translation or a horizontal stretch, right? When it's with the x, that's our only option. So it's a horizontal stretch by a factor of what? 1/5. About the y-axis because it's with the x. So it's about the opposite axis. So if it's with the variable, it's about the y-axis. It's going to affect the x's. You do this one. Sketch it. What's my mapping going to be? xy becomes 1/2 x comma y. So it squished it, which makes sense because all my x's got halved, right? So a wider graph would now be narrower. So it's the opposite of vertical. Vertical, when your y is a fraction between 0 and 1, it actually gets it wider. For horizontal, it squishes it. We're going to flip to example 5 due to Friday. Okay. There's things together. So many things, so little time. Okay, literally. Yeah. Describe the transformations that occurred if the original function was y equals x squared and the new function is this. So let's go through, and if it's an x squared like this, I will always bracket my x if it's not already bracketed. So if you look in B, this whole thing is bracketed, so the whole thing is x, correct? If you look in C, this part's bracketed, so that part's x. We agree? If you look in A, is there anything bracketed? No, so then I put brackets because it's just there. Because if this 2 was part of this, it would actually be a what? A positive and a 4x. Because you'd bring the 2 inside the bracket, which would make it be 4, because you'd have to square it to get it into here. We're not doing that, though. We're leaving it where it is. So if the x doesn't have a bracket around it, put a bracket around it so you don't think it's horizontal. Is anything happening to the x here? Nope, my x's are staying the same. Let's do mapping for a second first. So my xy is going to become x. Nothing's happening there, right? What happens with this negative 2 in front? I just multiply by negative 2. And then what about the plus 3 at the back? Add 3. It's the great thing about the y's. If you have it in y equals, whatever these numbers are, they just stay the same. If they're in y equals. If you leave them on the other side, you have to flip them. Change them, except for the negative sign. So, what the heck does this mean in transformation? So we start off with stretches first. This 2 is a stretch, correct? And what kind of stretch is it? Vertical. So it's a vertical stretch by a factor of 2 about the x-axis. So it's about the opposite. And it's not negative 2, right? Because the negative is actually a reflection in the x-axis. It's always the opposite. So those all affected y's, so they're all going to be in the x-axis. And then my translation, going back a couple days, this is a what translation? Vertical translation. 3 what? 3 up. So these all affected y's because none of them was with the x. We agree? What's up with b? They all affect x. Now this is the catch. This is the catch. If you see it like this, negative 2x plus 4 squared, our rule was, when we did horizontal, let's go back. If I gave you x plus 3 squared, you would tell me that was a horizontal translation. This is very lazy. Don't do this on a test. 3 left. Right? That's what you told me. What was in front of the x? A 1. So that rule only worked when there was a 1 in front of the x, didn't it? You just didn't even know that. You just trusted me. You're like, boom, there's a number. Yeah, horizontal translation. But till this moment, you didn't realize that it only works because you had a 1 in front of that x. Because I never gave you it without a 1. We agree? Do I have a 1 in front of my x currently? No. So this is a standard of excellence question. If they don't have the number, a 1 in front of the x, you have to take that number, GCF it out. Or your horizontal translation is going to be wrong. So we have to do a step first. So we're going to take the negative 2 out of this bracket because we want to get, well, not out of the bracket, out of the x. So we're going to keep the bracket still. Negative 2 bracket, so we're GCFing it. Now we get 1x, which is what we need, right? But it also affects this 4. When I take a negative 2 out of 4, what do I get? Negative 2. So this actually isn't a horizontal translation 4 left. It's actually 2 right. And if you forget to take that GCF out, you will get your horizontal translation wrong every time. And do you think that answer will be there, the wrong one? Yep. And often, for the AP exams, people do really, really well in the transformations or poorly. And often the poorly is because they forgot to take the GCF out the whole freaking time. Freaking time. I didn't say the real word, but I just want to clarify that that's what I said. All right? Okay. What's my stretch? Oh, and people will say it's not with the x anymore. If I distribute it back in, is it still with the x? Yeah, so it's still with the x, you guys. This is still, people will try and tell me it's vertical. It's not vertical. It's still squared. It's still with the x. I can still distribute it back in. It's still an x situation. So my stretch is a horizontal stretch by a factor of, what do I do with horizontal stretches always? Flip them, so it's going to be 1/2 about the opposite axis. So if it's horizontal, it's about the y-axis. There's a negative, so there's a reflection in the y-axis. And there's a horizontal translation to right. Do you see how it gets much more complicated when we have way more things? If I went to do mapping, my mapping and my words are the same. So my x would be negated and multiplied by 1/2. And then I would add 2. And my y would stay the same because nothing happened. So it gets much more complex when we add more things. Now your homework for this won't be all these mixed together, right? It's just stretches. I just wanted to show you where we're going. We're going to this. So when people are like, I don't need to do the homework for these other ones because I just rock them. Remember, they don't stay that way. They don't just stay with a stretch and then they're just so nice to give you one thing. Okay, if they give you 2, it's still an acceptable standard. If they give you stretch, reflect, and translate, it becomes a standard of excellence. The same homework page as last day. You know what? Don't do number 2. That's so much work. We're going to do number 5. A, B. 6. And 7. I normally give 2, but it's a lot of sketching.